Welcome! So glad you could make it. This is Emmett, and in today's video we'll be tackling this problem. The equation y equals x squared and the polar equation r equals 5 minus 4 cosine theta create an enclosed area with the x-axis in the first quadrant. Determine the area. So as always, pause the video, try it out, and get back to the video when you're ready. So I'm going to first draw out the first quadrant and then sketch y equals x squared, which you should be pretty familiar with. And then using the help of a graphing calculator, I can sketch what the cardioid 5 minus 4 cosine theta looks like. So it looks something like this. And so what we need is this area here. But the problem is we have a rectangular equation, but then also a polar equation. And so we're going to have to convert one into the other form if we can then integrate and then subtract the areas. And so you can try converting this to rectangular, but that'll be a little tricky. So I'm instead going to convert y equals x squared into polar form. And then what we can do is subtract this area here, which is the integral of y equals x squared in polar form from the angle 0 to this angle, and subtract it from the integral of r equals 5 minus 4 cosine theta from 0 to this angle. So let's start by doing that. So in polar form, you're dealing with radius lengths and angles to pinpoint locations. But what we need is x and y coordinates. So what we can do is use these two equations, where x equals r cosine theta and y equals r sine theta. And we can use these two equations to convert this rectangular equation into a polar equation. So let's substitute in. So for y, we have r sine theta. Keep in mind I'm just substituting into y equals x squared. And then we have, for the x, we have equals r cosine theta, plugging in for x, squared. And so now we have r sine theta equals r squared times cosine squared theta. And we want to isolate for r. So we can divide both sides by r, and that leaves us with sine theta equals r cosine squared theta. And now isolating for r, we get r equals sine theta over cosine squared theta. And so now we have both y equals x squared and this polar equation both now in polar form. And we're back with some color. So what we need to do first is find this angle, because if we can integrate the red equation from 0 to this angle, we get this area here. And I'm just drawing out the extending radii. There'll be, infinite. And then if we integrate the same from 0 to this angle for the blue equation, we get this area here. And as you can see, if we subtract this blue area from the red area, we get this yellow area. So let's find this angle. Okay, so because my calculator doesn't allow me to find intersects in the polar plane, I'm going to use a little bit of a workaround. I'm going to let r equal y. So for this equation, we have y equals, and then I'm going to have theta equal x. And so this won't look the same when I graph it in rectangular form, but it will still have thetas and radii. And so let me do the same for the other equation. We have y equals 5 minus 4 cosine x. And now when I graph these two equations, I can find where the radii are equal given theta. So graphing the blue equation, actually I'll start with the red equation. It looks something like this. And the blue equation looks something like this. And so the intersect is right here, where x equals 0.994 and y equals 2.819. And so the y value is the radius length, which we don't really care about, because what we care about is the theta, the angle. And so theta equals 0.994. So polar integration can now be used to find the area in red, blue, and then finally yellow once you subtract. So let me write out the polar integration for the area in red. Now subtracting the area in blue. Which gives a final area of 0.85995. I hope this problem was interesting. Before you leave, I would like to pose this last question. What is the maximum y value for y equals x squared in polar form on the interval 0 to 2 pi? So I'm not going to explain it in this video, but if you'd like to see the solution, there is a packet linked in the description of all of our videos. As always, thank you for watching.